Hello, dear friends. It's me, Dr. Mazhar Ali, and today I'm going to present some research studies and updates which are done in the field of computer science, especially in the field of artificial intelligence. These are very much important updates and research study that may be very much beneficial for you. So, if you are general audience, then you may get the knowledge information that where world is going. If you are students of computer science, you may get great knowledge that what should you focus. And if you are a researcher in the field of computer science and artificial intelligence, you may conduct research studies on the fields which I'm going to discuss to you. So let's discuss the research studies. A very good research study is conducted on underwater messages. This studies produce a software application that is named AquaApe. Researchers at the University of Washington show how to achieve underwater messaging on billions of existing smartphones and smartwatches using only software. The team developed Aqua App, the first mobile app for acoustic based communication and networking underwater that can be used with the existing devices such as smartphones and smartwatches. Smartphones rely on radio signals like Wi Fi and Bluetooth for wireless communication. Those don't propagate well underwater, but acoustic signals do, said co lead author Tao Chu Chen, a PhD student in the Allen School of University of Washington. We demonstrate underwater messaging using the speaker and microphone widely available on smartphones and watches. Other than downloading an app to their phone, the only thing people will need is a waterproof phone case rated for the depth of their dive. The Aqua app interface enables users to select from a list of 240 preset messages that correspond to hand signals employed by professional divers, with the 20 most common signals prominently displayed for easy access. Users can also filter messages according to 8 categories, including directional indicators, environmental factors, and equipment status. This is a great research and opens doors for new researchers or those researchers which keep interest in doing research on such topics. Another research is done on fluid mixing. A topic of this research is mixing things up, optimizing fluid mixing with the machine learning. This research has conducted in the field of artificial intelligence using the machine learning. Fluid mixing is an important part of several industries, processes, and chemical reactions. However, the process often relies on trial and error based experiments instead of mathematical optimization. While turbulent mixing is effective, it cannot always be sustained and can damage the materials involved. To address this issue, researchers from Japan have now proposed an optimization approach to fluid mixing for laminar flows using machine learning, which can be extended to turbulent mixing as well. Mixing of fluids is a critical component in many industrial and chemical processes. Pharmaceutical mixing and chemical reactions, for instances, may require homogeneous fluid mixing. Achieving this mixing faster and with less energy would reduce the associated costs greatly. In reality, however, most mixing processes are not mathematically optimized and instead rely on trial and error based empirical methods. Can an optimized mixing be achieved for laminar flows instead? This is a question. So, to answer this question, a team of researchers from Japan in a new study turned to machine learning. In their study that is published in scientific reports, the team resorted to an approach called reinforcement learning, in which intelligent agents take actions in an environment to maximize the cumulative reward. Since Reinforcement learning maximizes the cumulative reward, which is global in time. It can be expected to be suitable for tackling the problem of efficient fluid mixing, which is also a global in time optimization problem, explains Associate Professor Masonobu, the corresponding author of the study. Personally, I have a conviction that it is important to find the right algorithm for the right problem rather than blindly apply a machine learning algorithm. Luckily, in this study, we managed to connect the two fields, fluid mixing and reinforcement learning, after considering their physical and mathematical characteristics. The reinforcement learning algorithm is usually formulated in terms of a Markov decision process, commonly called MDP, a mathematical framework for decision making in situations where the outcomes are part random and part controlled by the decision maker. Using this approach, the team showed that reinforcement learning was effective in optimizing fluid mixing. So, dear friends and researchers in Japan have proposed machine learning based approach for optimizing fluid mixing for laminar flows. The researchers used reinforcement learning, as I told you already, in which intelligent agents perform actions in an environment to maximize the cumulative reward. The team addressed reinforcement learning's inefficiencies in dealing with systems involving high dimensional state spaces by describing fluid motion using only a single parameter. The reinforcement learning method also enabled effective transfer learning of the trained mixer, significantly reducing its time and training cost. Language is a very important tool for communication and identifications of the nations and society. Therefore, UNESCO focuses a lot on the languages. A new research study in the field of artificial intelligence is done on learning the patterns of human languages. This study is titled as Artificial Intelligence Can Learn the Patterns of Human Language. AI that can learn the patterns of human languages on its own, a new machine learning model discovers linguistic rules that often match up with those created by human experts. Human languages are notoriously complex, and linguists have long thought it would be impossible to teach a machine how to analyze speech sounds and word structures in the way human investigators do. But researchers at MIT, Cornell University, and McGill University have taken a step in this direction. They have demonstrated an artificial intelligence system that can learn the rules and patterns of human languages on its own. When given words and examples of how those words change to express different grammatical functions like tense, case, or gender in one language, this machine learning model comes up with the rules that explain why the forms of those words change. For instance, it might learn that the letter A must be added to end of a word to make the masculine form feminine and Serbo-Croatian. So this model can also automatically learn higher level languages patterns that can apply to many languages, enabling it to achieve better results. The researchers trained and tested the model using problems from linguistics textbooks that featured 58 different languages. Each problem had a set of words and corresponding word form changes. The model was able to come up with the correct set of rules to describe those word form changes for 60% of the problems. So, dear friends and researchers, this is a really important study on the languages. If you are interested in NLP and computational linguistics and machine learning, you may work on your mother languages, your national languages. Another research study is done on tracking. This study is also done in the field of artificial intelligence. This research study title is a Pet Track Lets Owners Know Where Their Dog Is. The pay-trick system developed by the Georgia Institute of Technology, Georgia Tech researchers uses a combination of sensors to tell pet owners where their animal is in real time. So pet track comprises two things. One is knowing the pet's indoor location, and second is trying to understand their activity. Said Georgia takes Ashutosh Dekne, a device that can be attached to a pet's collar features ultra wideband or radio wireless sensors to determine the location of the animals from up to 100 feet away. Users can view this information through a smartphone application. Dhickne said, together combining where the pet is and what the orientation of the pet is, we can create a summary map of where the pet has been during the day and what activity the pet was doing. So this means owners can learn whether their pet is standing, sitting, or even lying down. So, friends, this research study is also important and opens doors for various types of the research studies on various type of the problem. You may track not only your pets, but you may develop a system for blinds, for other people, for your other entities that may be the living entities, that may be the non-living entities. I'm sharing another research study to you, that is the driving simulations that look more lifelike. Today's driving simulations have a big problem. They don't look realistic enough, particularly background objects such as trees and road markings. But researchers have developed a new way to create photorealistic images for simulators, paving the way for better testing of driverless cars. Conventional computer graphics use detailed models, meshes, and textures to render 2D images from 3D senses, a labor-intensive process which produces images that often fall short of being realistic, particularly in the background. Yet, by using a machine learning framework called Generative Adversarial Network, or GAN, researchers were able to train their program to randomly generate lifelike environments by improving the program's visual fidelity, the level of representation computer graphics share with the reality. So this is especially important when testing how humans react when they are in a driverless vehicles or alternatively on the road with them. Ohio State University researchers trained a generative adversarial network to create a random photorealistic three-dimensional scenery for driving simulations. The researchers based their simulator on the open sources Carrara tools, then applied a GAN-based image synthesizer to render and integrate background elements with the more conventionally rendered objects. The researchers determined that combining foreground objects separately from background scenery resulted in an image that was more lifelike. A research study on 3D artificial pneumatic muscles for future makers is also a significant research study. Researchers at Italy's Istituto Italiano di Tecnologia, the Italian Institute of Technology, and the Scuola Superiore Santa Ana, the Santa Ana School of Advanced Studies, have developed artificial pneumatic muscles that can be produced using three-dimensional or 3D printers. The researchers demonstrated a pneumatic hand made of 18 grace stand for the geometry based actuator able to contract and uh, elongate. Actuators shaped like a spindle with the pleats allowing them to expand, extend, and contract with little pressure, said IIT's Corrado D. Passel. Their size is limited purely by the manufacturing technology used. They can be built in different sizes and we can vary their performance both in terms of deformation and strength and manufacture them using various materials and technology even already built into the structures to fabricate it. So, friends, artificial pneumatic muscles consisting of 3D printers structures that can extend and contract as required. This is the innovative design of the Grace actuators. The creation of artificial muscles is a very ambitious goal in the field of robotics because in nature, muscle tissue has complex characteristics that permit highly versatile movements from rapid, powerful contractions to small and precise changes in body shape, such as those of human facial expressions. Although individuals' muscle fibers can only contract, it is their specific arrangements in complex muscle architectures that enables articulate deformations such as bending, twisting, and antagonistic movements. Another study has been done also in the field of artificial intelligence, and that is very much important. A robot dog can learn to walk on unfamiliar and hard to master terrain such as grass, bark, and hiking trails in just 20 minutes, thanks to machine learning algorithm for solving such type of the problem. So most autonomous robots have to be carefully programmed by humans or extensively tested in simulated scenarios before they can perform real-world tasks such as walking up a rocky hill or a slippery slope. And when they encounter unfamiliar environments, they tend to struggle. Now, Sergey Levin at the University of California, Berkeley, and his colleagues have demonstrated that a robot using a kind of machine learning called deep reinforcement learning can work out how to walk in about 20 minutes in several different environments, such as a grass lawn, a layer of bark, a memory foam matrices, and a hiking trail. The robot uses an algorithm called Q-learning, which doesn't require a working model of the target terrain. Such machine learning algorithms are usually used in simulations. We don't need to understand how the physics of an environment actually works. We just put the robot into an environment and turn it on, says Levin. Dear researchers and dear friends, dear viewers, researchers at the University of California, Berkeley developed a machine learning algorithm that enabled a robot dog to learn to navigate different terrain in only 20 minutes. The Q-learning algorithm does not need a model of the target terrain. Algorithm teaches the robot by rewarding it for each successful action until reaching its ultimate goal. So this is also a great research study that is done by researchers at Berkeley. So if you are interested, you may do and conduct such type of the studies. Thank you very much for watching this video. I hope this discussion will be beneficial for you. If you have not subscribed to my channel, please subscribe to it. Press this red button and also press bell icon that you may get notification of my upcoming videos. Take care. Stay blessed.